Have you ever really looked at your internet bill and just wondered, what is going on behind the scenes here? I mean, it seems simple, right? You pay and you get online. But underneath that one transaction, there's this incredibly complex web of technology that doesn't just process your payment. It's actually controlling your connection to the internet in real time. So today, let's pull back that curtain and see how a simple payment actually commands the entire network.
You know, this question, it's pulled from a software review, but it really hits home for so many businesses. You've got manual invoices, you're chasing down payments, records are all over the place. It's a universal headache. For a lot of companies, billing is just this messy, necessary evil.
So, if you're running a business, how do you fix that? How do you turn that total chaos into something efficient? Well, the answer seems pretty straightforward at first, but as we're about to see, it gets way more interesting when your product is the internet itself.
Okay, so for most businesses, the hero of the story is modern billing software. These platforms are designed to just take all that manual work and all that guesswork right out of your finances. They turn a major pain point into a smooth, automated process.
So, remember that chaos we just talked about? Well, this is the fix. Automation means no more forgetting to send a bill or having to chase down late payments. You get clear, real-time tracking of your money, not some messy pile of papers. You get secure records, which is crucial, and you can even message customers directly through the platform to keep everything organized. It's the whole shebang for turning that headache into a well-oiled machine.
But here's where our story takes a really sharp turn. Because for an internet service provider, an ISP, billing isn't just about collecting cash. It is fundamentally tied to the service they are delivering second by second, and that is a whole different level of complexity.
Think about it. A typical business, they sell you a coffee or maybe a shirt, and the transaction is pretty much done. But an ISP, they are constantly managing your access. Is your account paid up? What speed are you supposed to be getting? Have you hit your data cap for the month? The billing system has to answer all of these questions, and it has to do it instantly.
And that means an ISP's billing platform is also its network management platform. It's doing everything from handling prepaid vouchers and tracking data quotas to literally telling the network hardware what speed to give your specific connection. It has to authenticate every single device that tries to connect. This is so far beyond just sending an invoice. This is about actively controlling the entire service.
So how on earth does a billing rule translate into a real-time action on the network? Well, the magic behind all of this is a framework that's been the bedrock of network access for decades. It's called AAA.
AA stands for Authentication, Authorization, and Accounting. The easiest way to think about it is like the security at a really exclusive club. First, the bouncer checks your ID to prove you are who you say you are. That's authentication. Then, they check the list to see what you're allowed to do. Can you go to the VIP lounge, the main floor? That's authorization. And finally, they're keeping a tab of everything you order all night. That's accounting.
And that is exactly what happens with your internet connection. The moment you try to get online, the network authenticates your device. Then it authorizes you for a specific speed based on your plan. And all the while, it's accounting for every bit of data you use, which, of course, feeds right back into your next bill. Every single online session you have goes through this three-step dance.
So this AAA framework is a really powerful concept. But for it to actually work, computers need to speak a common language, a protocol. So let's look at the protocols that bring AAA to life, starting with the original workhorse.
The original protocol was called Radius. And yeah, as the name suggests, it was developed way back in the dial-up era. For a very, very long time, it was the gold standard for authenticating users. It's a really robust, reliable protocol that basically laid the groundwork for everything that came next.
But Radius, it was designed for a simpler time. As networks got way faster, way more complex, and especially more mobile, with things like 4G and LTE, its limitations really started to show. The industry needed something more powerful, more flexible, and honestly, just more reliable.
And that's when diameter showed up. As its name kind of cheekily suggests, a diameter is twice the radius. It was a huge evolution. You can see the key upgrades right here. It uses more reliable ways to send messages like TCP, which basically guarantees they arrive. It has failover built right in, so if one server goes down, another one can just take over. And what's really crucial is that it's way more flexible, which is why it became the foundation for modern 4G and LTE networks.
But all this new power came with a new problem. In a diameter network, every single element can talk to every other element, which creates this super complex mesh. Think of a tangled ball of yarn. It's really hard to manage. So the solution was to add a new piece to the puzzle, the Diameter Signaling Controller, or DSC.
It basically acts like a traffic cop, turning that messy web into a simple, clean, and manageable hub-and-spoke system.
Now, these principles, authentication, authorization, they're not just for your internet connection. They are the fundamental building blocks for secure digital transactions everywhere, and they operate on a scale that is just mind-boggling. Just take a look at this number. 1 billion. A company called Onafric connects over 1 billion mobile wallets across the African continent. 1 billion. How is that even possible?
Well, it's possible because of the very same AAA principles we've been talking about this whole time. Every single time someone makes a payment, their identity is authenticated, the transaction is authorized against their balance, and the transfer is accounted for, all in real time. It's the AAA framework that lets this massive, incredibly complex network run securely and instantly.
So, let's bring this all back home. The next time you tap your phone to pay for coffee or send money to a friend, or even just glance at your monthly internet bill, just remember that there's this invisible, high-speed conversation happening in the background. It's this hidden journey from that simple line item on your bill, all the way down to the powerful AAA frameworks and protocols like Diameter that are authenticating, authorizing, and accounting for every single one of our digital interactions. But technology never stands still. We went from radius to diameter because the world's demands changed. So as we move into an era of smart homes, connected cars, and literally billions of new devices coming online, you have to wonder, what's next? What new protocol is going to be needed to manage a world where everything and everyone is securely connected?